everyone, and welcome to the first California Academy of Sciences Tour of the Universe of 2023. Hopefully make it a good year. They left the keys in the ignition for the rocket we're taking today on this tour, so I just snuck in and I'll be driving. My name's Hayden with the California Academy of Sciences, and I'm glad to be here for my first live stream to take you all through a tour. And what better way to start here than above our big blue ball we call Earth. So, if you have any questions as we're taking this, feel free to post in the chat. We're keeping an eye on it. You're welcome to click any links that we'll drop as we're kind of going through the tour. We'll have more information about the topics we're discussing. So just click on that, follow for more if you're interested. Feel free to ask questions too. If we have anything we can answer to get back to you, we will do that when we can. And if you're wondering what we'll be using to actually take this tour today, we are using a little program here called OpenSpace. It is an open source software that is supported by NASA. And if you, during this tour, you decide this is a pretty nifty thing and you kind of want to take a peek yourself and try it out, well, you can. If you go to OpenSpaceProject.com, you can actually look at the specs required for what you might need to have on your computer to run it yourself, and then you can just download it and kind of take it for a spin. Check out all the various stars and just see what kind of tour you can make. But like I said, we're going to start off this tour here at the International Space Station, sitting here above Earth. So the International Space Station is actually about 400 kilometers above Earth's surface. And taking a look at it, it's, it looks pretty big. And I think from tip to tip here with the solar panels included, it's actually about the size of a football field. But the International Space Station is pretty much as far as we go out into space these days. There's kind of a various amounts of countries. I think it was about 16 involved who send crew up now and then to man the space station. So it's usually occupied by different folks for about 6 months at a time. And this is pretty much the extent of how much we travel in space currently. And if you ever peek up at night when it happens to be overhead, which, if you're ever curious, there's plenty of sites that actually will track the International Space Station's position. So you can go check those out. Google search would help you find it too. But if you ever look up at night, you can actually see the space station with the eye. No tools required. So you can just take a look for yourself. It circles the Earth about once every 90 minutes or so. And is quite a wonderful piece of equipment that we've made. But that's where we'll be starting our tour for now. And I can even show you here, if we toggle the orbit, you can see where it is traveling around the Earth as it makes its way through space. And like I said, about every 90 minutes or so, it'll pass around once. So it's a fairly swift, if you think about it, compared to, a normal 24-hour day for us, for me and you to see day and night. But space is not just right above us here. What we'll be going to next, actually, if we want to back out a bit, is we will be going to our favorite nearby friend, who I like to call Luna, the moon. And as we pull away further and further, kind of get an idea of just how small that space station actually is. And now to help us find the moon, because, space is a pretty big place, we're going to toggle the orbit and see if we can take a peek around and find it. Also, just a note, if you ever notice, there's some odd images here with the Earth. This is actually all live data that we have of the Earth. This is, actual images. So certain areas where we don't have data or things aren't necessarily loading correctly, that's why you might see some discrepancies, but it's all actual live time footage and images. But going back to the moon, as I mentioned, that is where our friend is. So we will move onwards and say hello. Now, though the International Space Station is about how far humans are kind of going into space currently, the moon is the farthest that we have ever been ourselves. So the moon is about 400,000 kilometers away, and in the 60s and 70s, we had sent our manned missions to the moon to actually explore it ourselves, to set foot on it. Now, something we don't do, unfortunately, currently, but who knows, as time goes on, we may be, I think, including soon, we have plans to stop by and see it again. So we look forward to that. So the moon itself, as you can kind of see from the surface here, it's very rocky, lots of craters around here. It is got no atmosphere. It's just kind of a big hunk of rock in space, but you know, it's one that we are very familiar with, see it up in the night sky all the time. And it's a very kind of a chilling place to look at it from some of these angles you don't normally see in this close up. It's taken a lot of hits from various debris over its existence, but it's still chugging along. So to actually, you know, get to the moon, like I said, it's 400,000 kilometers away. That's a pretty long trip. But if you were, say, traveling at the speed of light, which is about 300,000 kilometers a second, that would actually, trip would only be about 1.5 seconds, a little bit less than that actually. So if you think about just taking a peek at the moon, count it for about 1.5 seconds, and you'd be there if you were able to travel at that speed. Obviously, we can't really do that right now. Thanks to the technology of OpenSpace here, we can move pretty quick though, so it doesn't take us that long to go visit some of these places. But that's where scientists like to measure distance, not in miles or kilometers at this point, because things are just getting too big. Distances are getting too large. That's where we have to start measuring in that speed of light. And so that 300,000 kilometers for a second speed of light travel, that's what we're kind of working with. But the scale gets even bigger as we go. And so to continue on that theme of things just growing, we're going to pull out even more away from our moon and see where we are in our solar system. So, you know what, let's actually focus also back here on our Earth and pull out until we see where the rest of our solar system friends are. And I just turned on the planet trails so you can start seeing all the other trails of the planets that are traveling along currently. And there, right in the center there, that is our sun. So here's where we are at currently, relative distance-wise. And then right there, front and center, that's Mercury, first planet from the sun, followed up by, we have Venus, and then Earth, us at number 3, and then right past us is Mars. And those are the kind of the 4 first planets that are close to the sun before we end up reaching the point where we've got a whole belt of asteroids that sit right here between kind of this open space past those 4 planets. And a few other things. Actually, I didn't mean to show that right away. A little bit of a preview there. But as we pull back more, we can start seeing the other 4 planets that we've got. Jupiter coming up next at number 5, followed by Saturn, Uranus, and then Neptune. So obviously, Earth's a pretty big place for most of us, but when you actually kind of scroll out and look at the entire solar system, we're just a pretty small bit of it in the grand scheme of things. And if you want to see what I showed you a little bit there earlier, those yellow trails that you're going to see pop up here in a second, these are spacecraft that we had actually sent out. They weren't, you know, we weren't manned inside of it. We haven't gone this distance, but these are spacecraft that we've sent out, you know, through our solar system and past it, that are pretty much the farthest things that we've actually sent out ourselves. So in terms of distance that we've managed to actually put out with our own equipment, this is as far as it goes. But the solar system's not the only thing that we've got going on, because we're in a pretty big place here. So we're going to scroll out even more, even further, until That sun is just a bright light in the darkness. And you're going to start seeing these other kind of lights, and those are other stars nearby as well. And speaking of our influence, though, this big blue ball here that you see is called the radiosphere. It is a sphere of basically energy that we send out, radio signals, for the past 100 years or so that we've been putting out that have gone that distance with us kind of at the center there. And so this is pretty much our, you could call it our footprint in space. Activity that we've done for the last 100 years have kind of sent out signals that have leaked through the atmosphere and have created this sort of bubble that if anyone inside of that bubble who had technology or means to read it could see that we're there, that we're right in the center. And in terms of what's actually in that little bubble there, there's plenty of stars, and some of those stars, like ours, have planets that are around them. And those are called exoplanets. And I will show you here all of those little circles in and out of that orb are stars with planets around them, exoplanets that we've been able to record. Now, there are likely many other exoplanets around that we haven't necessarily recorded. These are ones that we know are there. And so you can see that, you know, there's a lot of other neighbors nearby that are in our little bubble that would be able to, you know, if they had the means, if someone was there, they could know that we have been doing something for the past 100 years from our radiosphere signal. Excuse me. And so this is our furthest evidence that humanity kind of exists, and it's still expanding to this day. But again, kind of as we keep pulling out more and more, you'll see that it's still just a small bit of the grand scheme of things. Excuse me. So we'll pull back further and further. Turn off those exoplanets too, just to get a little bit of clarity. But now we're at a point away from just our planet and our solar system. We are now at the Milky Way, our galaxy. So this is just our little spot. You can still kind of see it there with that little bright dot there. Our position in the Milky Way, which is just a flat spiral disk of hundreds of other stars besides just ours. So this is full, like I said, of other stars that are always, you know, this is energy that's expanding, and the Milky Way galaxy is not the only galaxy, obviously, around here. As we keep going, you can kind of see here to the sides, but there's plenty of other galaxies besides just ours as well. And those galaxies similar to ours are just expanding outwards as time goes on, slowly but surely. And the closest other galaxy that we have, the Andromeda galaxy, is 2.5 million light years away, which, just to put that in perspective, means that the light we see from that galaxy, because you can see the Andromeda galaxy, again, I believe in the night sky with just your eyes, if the time is right and not too much light. But what you see is 2.5 million light years away, which means you're seeing that galaxy 2.5 million years ago. That's how long it took that light to get to us. And every other spot you see here in this void is just another galaxy. So that there's so many other stars, potential exoplanets there. And again, as we keep going out and out, further past our Milky Way, just into the general galaxy, you'll see that there's a lot there. So much. And we still haven't even recorded most of it. As we keep pulling back here, you're going to see this shape here. Take a look at that. It's very breathtaking. Now this kind of spiral shape you see here, these two cones almost, tip to tip. These are, like I said, other galaxies that we have recorded, that we've surveyed, that we know are there. And as we keep pulling back, there's just so many. And now, if you're wondering what's with the shape, you know, why is it that kind of two cones, that little spiral on both sides with this gap in the middle? That is just because with what we can record, the Milky Way itself, where we are at, we kind of block ourselves from recording in this space, kind of to the left and right of that. We're basically blocking ourselves from seeing what's there. So there's likely, obviously, much more there, similar to probably what we've got here. But in terms of what we can see, this is what we have so far, and it makes this kind of lovely shape in the meantime. One day we'll be able to map that out as our technologies improve. And just to keep things in perspective, these galaxies here, these are billions of light years away at this point as we keep going out. So the Andromeda Galaxy, which was 2.5 million, and you know, if you saw that light, that means you were seeing it from 2.5 million years ago. These are now in the billions, so we are talking a long time here, very big on the scale. And we can still go further. It never stops, really. Well, eventually it does. Spoilers. But we'll keep pulling back further. These orange dots that you're seeing here, these are quasars, very energetic galaxies that we have surveyed. And as we pull back just a bit more, you see this orange background kind of surrounding everything. Now this is the cosmic microwave background at the edge of our observable universe, essentially. This is pretty much as far as we can record or survey anything, the light that we're able to see with our tools. Essentially, kind of at the beginning of the universe there, light was kind of trapped in a little space, couldn't really move much, and then as things cooled down, the light was able to escape and move, and that expanding light is that cosmic background that you see there, that orange wall. And that light is still going, even now. It's continuing to expand, but this is pretty much as far as it's gotten so far. It's the furthest thing we can detect, so that's why we call it the edge of the observable universe. And this is, again, billions and billions of light years out there. This would take a long time, even traveling as fast as we could, light can travel. It would take you billions of years to get remotely close to any of this. So the universe is a big place, a lot bigger than you probably thought, just from the start there when we were sitting at the ISS. And as we go back home, hopefully that sense of scale sinks in, and we'll start traveling now. So we say goodbye to the cosmic microwave background there. Start scooching in past some of those more distant recorded galaxies into more familiar territory. Again, every one of these lights that's zooming by, just another galaxy full of stars, full of planets. We're seeing the Milky Way again, with that little blue ball, us and our radiosphere. And as we get closer and closer, we are now back inside of that footprint that we've left, and still plenty of time and space to go here. And now we're starting to see the light of our sun a lot more clearly. As we come in, I'll turn off those trails from our little friends out there. Show our planets once more. And we will keep going. turn off that radiosphere so we can get a good view of our home. As we end up past the moon once more. There it goes. Say hi. And land right back here on home. Isn't it lovely? So, again, just wanted to say thank you for coming to the tour of the universe here. It was very lovely to be able to take you all with me on that for my first time. And hopefully that little bit of a trip there gives you a nice sense of scale of just how big the universe is and how much we have discovered and still have yet to discover. Never let that spark of imagination and wonder ever leave as we just kind of together try to figure out what we've got out in the universe. So thank you very much. It's been a great time, and I hope you have a good day.